We're beginning the second big set of topics in chapter 5 now, and it's oxidation and reduction, or a shorthand that you'll hear me say sometimes is redox for those. And this fits in, again, just back to our first page here. We're talking about chemical reactions. Everything we've done so far, we've been counting atoms, but now we're going to take a look at electrons and also be using atoms still too, but we'll be looking at changes in bonding, and we're going to be counting atoms and electrons in this segment here. And this is really important because ultimately what's keeping us alive, what's keeping our cars running and our phones running is moving electrons around. And so we want to have a very good, solid, basic understanding of what does it mean to move electrons around. And two words we use to describe moving electrons around are oxidation and reduction. Oxidation we'll see is the loss of electrons from an atom, and reduction is the gain of electrons from an atom. And there's a little mnemonic that I write on the top of my paper still when I'm working these problems. Oil rig, oxidation is loss, reduction is gain. We're going to start with focusing on electrons, and then in a little bit we'll see some hydrogens and oxygens show up. So we're also going to be reviewing with charges. This is something we learned back in chapters 2 and 3. We're going to have reactions, of course, but we want to look at charges so that we can study up on the electrons that are present. And I'm going to use two different colors of pen as I work on this page. So when I look at a sodium, just a sodium all by itself, okay, I would say that this is a neutral atom. It's not connected to anything, it hasn't gained electrons, it hasn't lost any. So when I talk about sodium, I might write a little 0 up above it, or say that it has no charge, or another word I could use for that is that it's neutral. So you'll hear me use both of those, no charge or neutral. All right. Now, similarly, if I look at a chlorine molecule, which is the Cl2 here, these chlorines haven't gained or lost electrons. They're just sharing what they have to make their lives better or more stable, okay? So these chlorines, I could also write or draw a little 0 on it, and I would say that each chlorine has no charge because it hasn't gained or lost electrons. It's neutral, all right? However, once they become a compound, okay, and this is a bad model of this compound, right? But it's a sodium that's given its electrons to the chlorine. Now they have charges. And because it is an ionic compound, ionic compounds always have charges, okay? So this is where you might pull out your periodic table again to see what are those charges again. Sodium is here in group 1, and remember group 1 has positive 1 charges. Chlorine is in group 7, and group 7 has that 1 negative charge. So I could write those charges here: chlorine, -1, sodium, +1, and those are going to be essential in helping us figure out where our electrons are. So over here is another way to kind of look at this reaction. So we've got this reaction that we had seen before with our little atoms, right? When I start with this sodium that's neutral, another way that I could express that is I can look at this and I can say I have 11 protons and I have 11 electrons, right? They're equal to each other. That was something we did back in chapter 2. And then chlorine here, I'm going to look just at an individual element. So I'm going to say each chlorine has 17 protons and 17 electrons. Remember, the atomic number is where I'm getting those numbers from. So 17 and 11 is where I got those numbers from. Now, when this becomes an ion, a cation or an anion, this sodium has lost an electron. So each sodium is now 11 protons. That can't change, but only 10 electrons. And the chlorine is still 17 protons. That can't change, but it gained an electron, so it's 18 electrons. So I can see here in my counts that sodium has lost an electron by the end, and chlorine has gained an electron. As we look at this, you might notice there's some things that I ignored here, okay? And so I just want to jot you a little comment up top here. In all of this redox type of concept, we are going to suddenly ignore those coefficients that we paid so much attention to. And instead of looking at coefficients, we will count electrons or hydrogens or oxygens. So we're going to ignore those coefficients. That's okay. All right, so we can identify the charges, and any element by itself will always be neutral. So lonely potassium, lonely fluorine, if it's an element by itself, it has no charge. But pop it into an ionic compound, and now we're going to say, hey, that's got this charge to it. So here we counted our protons and electrons. The next way we want to look at this type of reaction is with Lewis structures. So Lewis structures we used back in chapter 3, right? So I'm going to stick with my colors here and say, here's my two sodiums. Sodium's in group 1, so when it's neutral, group 1 has 1 valence electron, right? Chlorine's in group 7, so each chlorine has 7 valence electrons. So I've got my sodium, and then I've got my chlorine. And if I wanted to, I could look at those from a particle perspective, right? So what happens as this reaction occurs is sodium's going to lose electrons and chlorine's going to gain them, right? And so here is what my products look like. Sodium says, nah, I'm going to get rid of that electron so I can have a full octet underneath in the next shell down. And chlorine says, you know what, I would totally take that electron off of your hands if I can pretend that these elements are humanish. And so each of those 2 electrons, I'm just going to make them X's so we can see them, help fill out the octet of chlorine. And as a result now, chlorine gained that electron and it has a negative charge. So this is illustrating what we see up here, just in a different way, okay? Kind of a more particle way. Finally, we want to put some labels on our chemicals. So oxidation is losing electrons, reduction is gaining electrons, and we will always label reactants only, not products, all right? So as we can see in this reaction here, or with the charges up here, sodium goes from 0 to +1. Sodium loses electrons, we would say, and that means that sodium is oxidized. I should be using red here probably. And we can say that sodium is the reducing agent. Reducing agents are oxidized and they help something else become reduced. So this is a reducing agent, and again, like red would be better for all of this. Reducing agent because it's donating those electrons over to help chlorine get reduced. Okay, look at my chlorine here. So again, I'm looking directly at the reactant. I would say that this chlorine gained electrons, which means it was reduced. Sounds kind of backwards. You're going to want to practice a lot with these terms because you gain an electron and you're reduced can get your brain a bit in knots. And then I would say that this is the oxidizing agent. Agents help athletes and celebrities and stuff, right? And so this is a helper, a helpful agent that helps this other compound get oxidized. So those are some different ways to look at the same reaction. We can count the particles, we can draw the particles, and we can put labels on. The labels are one of the main things we'll do throughout the rest of the chapter, but you need to be fluent in doing all of these things. So on the next page, you've got a whole different set of reactions. You can try these ahead of time or try and get stuck and bring your questions to class. We'll work on some of these together.